Hello, hello. Hi, this is Lynn, the CEO and the founder of EduCare Taiwan. And many of you already know, but I just want to say that again, that EduCare Taiwan is the largest and the only platform which consistently provide the correct and updated information about Taiwan higher education. So till now, there may be more than 100,000 students signed up for our webinar already. Many of them actually gather the information from the webinar, like the today what you are doing, and take the action to go to Taiwan and change their life to the better direction. So I hope today's you can benefit, get the positive, get the information and do the positive change in,
Okay, my lab is located in a hospital, which is about 5 miles away from the university. And currently, there are 1 PhD student, 3 postdoctoral, and 3 research assistants. And my previous students, some of them has been promoted as assistant professor at the MD Anderson Cancer Center.
Wow.
And also the associate professor at the Chang Memorial Hospital, Kaohsiung. And the 2 of MD students, one has been promoted as professor and assistant professor already. This is my background. I had my MD degree from Taiwan, PhD from USA, and currently I'm a professor. And I've been awarded several honors in the past several years, including one from the American Association Cancer Research, and some from our government academic awards. So my research interest focus on liver development, liver carcinogenesis, and how carcinogenesis allow tumor cell to evade the immune surveillance, and also gut microbiota and their roles in chronic and acute liver failure. So first, I introduce our liver development studies. We use mouse models and single cell RNA sequences. And we found that actually a liver development continues before, even after birth. And also birth probably have great impact on the different liver cell differentiation as well as maturation. So we want to know how birth impact the liver development, what's the mechanism involved. And also we have identified several novel subtype of cells in the liver, including a liver cell lineage as well as endothelial cell lineage. And we want to know their role in liver pathogenesis as well as carcinogenesis. We know that liver, histologically, the functional unit is lobular, and the liver lobular can further divide it into different zones, and even hepatocyte, where further differentiated for different biological functions. So we want to know how birth impact on such kind of maturation and the differentiation. So that's the example. We identified several novel subtype of hepatocyte. And regarding the carcinogenesis, previously we have used the RNAi methods that enable us to conduct genome-wide screening for oncogenes and tumor suppressor genes. And then we use molecular and cellular biology to stepwise elucidate fundamental molecular mechanisms that facilitate the tumor transformation. So for example, tumor cell can against the nutrition depletion, and also, for example, a tumor promote angiogenesis, and also how tumor cells to evade death induction, which is important for drug resistance, and also how tumor cell can count against the contact inhibition. We know that normal tissue cell-cell contact will limit cell proliferation and to restrict the overgrowth, but it's lost such kind of restriction in during tumorigenesis. We also identify the molecular mechanism that can be used to explain how large tumors tend to metastasis. And also, we identify the molecular mechanisms, how chemotaxis direct tumor cells migration to a specific direction. And we're also working on the so-called amoeboid migration as well. And we also identify genes that's involved in hepatitis-associated carcinogenesis. So currently, we are interested in how liver carcinogenesis induce immune evasion, because we know that liver cancer usually develops in chronic hepatitis and cirrhotic background. So carcinogenesis might endo liver cells during tumor transformation ability to counter against the immune surveillance and how it occurs. And then how can we use such kind of the findings to develop new strategies for anti-cancer therapy? So in this field, we know that whenever carcinogenesis, hepatocyte cells will have greatly changed their metabolism and will generate a lot of metabolite, including nucleic acid metabolite, protein metabolite, as well as glucose, sugar energy metabolites. And many of them might enable tumor cells to evade immune surveillance. So for example, this is an example when tumor cells, when tumor cells positive for the oncogen, actually, it will evade inflammatory cell invasion. So we want to understand how such kind of the immune cell insurance mechanism occurs, and then we can apply it for further therapeutic development. We are also interested in the role of gut microbiota in acute and chronic liver failure. So we identify significant microbes that's involved in the occurrence, recurrence, and the outcome of the cirrhotic patient, as well as we use mouse models to study acute liver failure and the role of the gut microbiota. So we did microbiota analysis. We also did metabolic pathway analysis and identify specific metabolite that might be clinically useful for treat or to reduce the severity of hepatic failure. We also work on the liver physiology and the pathology and to verify the identified metabolite that can reduce the severity of liver injury, and also the molecular mechanisms. So for example, we have published a paper in Cell Report early this year. We are also interested to know how the hepatoma incidence is so high in Taiwan. And by collaboration with the group in the Singapore, we found astrological acid involved in more than half of the hepatoma in Taiwan. That is, when chronic hepatitis patient took some herbal drugs containing astrological acid, then it will promote tumor development. And we use so-called molecular signature, mutation signature. We can identify such kind of mechanisms. For example, for the melanoma, the specific mutation pattern associated with UV. And for the lung cancer, the specific mutation signature associated with tobacco smoking. We also collaborate with several international famous groups and published several papers in high-ranking journals such as Cancer Discovery, Nature, Communication, Gut, and so on. So join us for science and also for translational research. Thank you. Thank you for your attention.
Thank you, Professor Xie. This is all too complicated beyond me, but I think it looks, just for your information, that Professor Xie had got a lot of award. I just got the information from Professor Chu. Good job. Very good. Thank you very much for sharing, sir. Thank you. And then our next presenter is Professor Yang. Okay, Professor Yang, the stage is yours. And team, that you can open up the chat. If any student who have any question, you can ask, and don't wait until the last moment, because we only really take few questions. Yeah. Without further delay, let's start with Professor Xie. Professor Xie, the stage is yours. Okay, go ahead, Professor Yang. The stage is yours.
It's my pleasure to share the research in our lab. So my research interest is about immunometabolic regulation that can be applied into different kind of clinical situations, such as tumor and kidney disease. So my major focus is CD4 T cell. The CD4 T cell it seems that it cannot make the movie work.
Yes.
Okay.
Yeah, it's moving now. Yeah.
The CD4 cell need to signal for activation, and the activation can lead to the cytotoxic T cell activation and also the B cell activation. So CD4 play a crucial role in the CD8 and human immunity. So it plays a central role in the acquired immunity. So I usually like to use this slide to show that the Star Wars, the key information delivered by the Star Wars is the Anakin Skywalker will destroy the Sith and bring balance to the Force. Why I show this slide because in my opinion, the key factor in immunity is balance. So in the COVID-19 world, you want a better immunity. It doesn't mean that the immunity is too strong. It means that the immunity is in the balanced status. In the Nobel laureate 2019, they are study about O2 sensing, and the application is about immunity. And I think our research in that time contribute this a little bit. CD4 T cell is divided into 5 subsets, and the most recent one is Th17 and Treg. And Th17 is about related to autoimmune disease or can increase the rejection of transplantation. And in the other hand, the regulatory T cell can suppress autoimmunity. So you can think that they play a role like yin and yang, the positive and negative. So if you can flip these two cells, you possibly can change the natural history of a disease. So in that time, we work with the Nobel laureate Grant Mensa to make a HIP-1 specific knockout mice in the CD4 T cell. So in the normal CD4 T cell in the Th17 environment, you can see a lot of IL-17 secretion, Th17 and no Treg, fast P3 positive Treg. However, in the HIP-1 knockout, you can see a lot of Treg and Th17 is gone. So it means that the positive and negatives is in the flap. Then thereafter, in the animal model, we show that the disease is gone in the HIP-1 knockout condition. So our work shows that the HIP-1 can control the balance of Th17 and Treg. So 10 years ago, we published a paper in Nature. Then 5 years ago, another related paper in immunity. But today, I will show you the most recent immunometabolic regulation story. Nowadays, people usually say that you are what you eat. It means that in addition to the energy, what you eat also influence the cell function and cell fat. In fact, this is not a new idea. 1,000 years ago, in the Han Dynasty, there's a ritual book composed by Confucius, saying that the commoners are brave and fierce, the grand eaters are wise and skillful. Those who eat breathe means qi, that's kind of energy, will be enlightened. And what is best? The best is no eating. No eating, you'll be like a god. And I think in the India, you also have this kind of idea. Nowadays, people know that some kind of fasting from the C. elegans to fly to mouse, we find that if you control the energy, you in fact improve the lifespan. And in the patient for chronic kidney disease, the clinical practice, we have to protein restriction for 30 years. We find that if we can restrict protein, we can mitigate the kidney function deterioration for the patient. And we want to ask, what if amino acid restriction, if we restrict one amino acid, will that be the better idea? So from my knowledge of immunology, I think glutamine addiction may be the answer. If you are doing cancer work, you know that cancer like to eat glutamine. If you did not provide glutamine, cancer will goes into apoptosis, cancer will die. And I think that maybe some inflammatory cell or immune cell also require the glutamine. And glutamine is a kind of semi-essential amino acid that it requires a lot, especially for the cell that needs to be preparated a lot. And in order to do the role of glutamine, we use a glutamine inhibitor called Gung. And we use a chronic kidney disease model called UO model. And normally you will see a lot of blue part, that means fibrosis. And if you do the animal model and adding the glutamine inhibitor, you can find the fibrosis is gone. So kidney function is much better. And also the fibrosis marker improve a lot. And we also do a single RNA-seq, and from the T cell, we find the CD4 and CD8 much mitigated. The activated form is decreased, and also CD4, TIF17, and Treg they are flip in the glutamine inhibition condition. So if glutamine really play a role, you can find that no more TIF17 condition, you can find a lot of IL-17 producing TIF17 cell. If the culture medium did not have glutamine, you can find the TIF17 is gone. You find a lot of regular T cell. So this pretty similar as our previous cell paper that the yin and yang is flipped. And we find that if you add glutamine in the glutamine-free condition, the later you add glutamine, the lower the TH17 and the higher the regulated T cell. And also in the CD4 T cell culture condition, we find that in the glutamine-free condition, if you did not give a glutamine, the GLUT1 is decreased. What is GLUT1? GLUT1 is the transporter that cell can uptake glucose. So if the cell did not uptake glutamine, did not uptake glucose for nutrition, for energy production, what kind of nutrient the T cell can use? I think maybe some of you already guess a lot is fats. And also from the study, we find that the fat transporter and fat enzyme is increased in the glutamine-free condition. And in fact, the fat is required for regular T cell production. So because time is limited, I just show you that in the normal glutamine condition, the HIF1 can stabilize, succinate can stabilize HIF1, and HIF1 can increase KTM4C. That can open the epigenetics of IL-17 to increase TF17. In other hand, the glutamine deprivation will increase the ROS, and ROS can open the promoter of FASP-P3, and FASP-P3 production can increase Treg. And in the other hand, the promoter of TF17 is closed, so TF17 is gone. But back to the initial single cell RNA-seq, not only CD4 T cell, the glutamine inhibitor also influence neutrophil, also influence monocytes, and all of them that leads to the reduced renal fibrosis. But we think that the CD4 T cell played a major role. How we prove that? We just did a adaptive transfer to transfer TF17 cell in the glutamine-free condition or in the control condition into the CD4 T cell free mice. And from the kidney filtration cell, you can find that as compared with the control, the FASP-P3 is increased in the glutamine-free condition, and IL-17 is decreased in the TF17 free condition. And also you can find the fibrosis part is much improved in the CD4 T cell that is in the glutamine-free condition. Another part I want to introduce is about the cancer, because though I'm a nephrologist, but our dialysis patient has been suffered from cancer. In fact, a patient with end-stage kidney disease have higher chance to get cancer as compared with the normal population. And the most common cancer in Taiwan for the patient with end-stage kidney disease is urothelial carcinoma. So again, we are thinking about if we can do some amino acid restriction, can we make some change? So we use different kind of culture medium and try to remove different kind of amino acids and to see what kind of amino acid restriction can activate CD4 T cell. Then we find that the asparagine deprivation, in fact, activate the CD8 T cell, because this kind of CD8 T cell can have granzyme B that can kill the tumor or have more interferon gamma production to inhibit the tumor. And in fact, there is a clinical drug called asparaginase. Asparaginase has been used in hematological tumor for a long time. They can be used in lymphoma and leukemia. A lot is because this hematologic tumor, they did not have asparagine synthesis. So they cannot de novo produce asparagine. So if you use asparaginase, normal cell is fine. However, the lymphoma or leukemia, they cannot produce asparagine. So these cancer cell will be die. But previously, people thinking that that cannot be applied into the normal solid tumor like lung cancer or colon cancer, because they can also produce asparagine. But my idea is, since asparaginase deletes asparagine, can activate CD8 T cell, we can use the cell to kill the tumor. So let's see if that is true. So from the epigenetic study, we find that the promoter and enhancer of NFACT are activated. And so that can explain why the CD8 T cell is activated, because NFACT is crucial factor for CD8 activation. And I missed some of the animal study. From the animal study, we proved that is true. And we applied to the patient with nasopharyngeal carcinoma, the NPC. So this is a patient stage 4 NPC. Initially, he has a lot of meta, including a sternal meta. And if adding the combination therapy with asparaginase and PD-1, you can find that the PET in the sternum, there's a mass here. And one day he come back to the OPD and say that I suffer a lot. There's a pain in my sternum. And we really find a mass here. So you can think about if tumor can progress so fast, just in 3 weeks. So this is pseudotumor. That is T cell infiltration. Let's see. This is 3 weeks later, when the tumor, when the T cell infiltration is mitigated and reduced, you can also find that the original tumor is gone. In addition, the EBV virus in Taiwan, the NPC is usually associated with EBV virus. The EBV virus decreased a lot. So immunometabolism for the better future. Welcome you to Taiwan. Thank you.
Okay, thank you, Professor Yang. Hello, Praveen. You're going to introduce CGU, right? Yes?
Yeah, I'll introduce CGU also now. Yeah, sure.
Go ahead, go ahead.
So good evening, everyone. I hope everyone are doing well. First of all, I want to extend my warm welcome to all of you who are attending this session. and my name is Praveen Kumar, and I am a PhD student here at the Chang University at Biomedical Engineering Department. I'm continuing my PhD under the guidance of Professor Thomas Kin Fong Lei, who was originally supposed to be present today, but he asked me to speak on behalf. So it's truly an honor to represent him and share some exciting insights about our institution and research labs with you. Okay, so the main picture which you are seeing is our main campus, called as the Chang University's main campus, where you can see the medical building and the engineering department, and as well as the management buildings to be integrated. So the integration is not only seen in the building, it's also seen in the programs also, where we integrate and collaborate with multidisciplinary projects. And we believe that in Chang University, that multidisciplinary action will lead to a scientific boom, and that could bring some positive impacts to life, because everything are nowadays connected, as we can see. Okay, so let me begin to give you an overview of Chang University. It is located in the Taoyuan city, which is near to the Taipei country's capital, and has an easy access to even to our country's international airport.
Your screen is so, the slide is not changing.
Yeah, yes, ma'am. When I move to the professor slide, I will change it out.
Okay, got it. Ha.
Yeah, yes, ma'am. So our university also has a state-of-art academic environment, as Lynn ma'am said earlier. Yeah, we have cutting-edge research facilities and global collaborations. We have strong foundation in education and as well as research, with an emphasis on interdisciplinary learning and innovation. And speaking about the Chang University, definitely it's a breathtaking moment, and you will feel proud that yeah, you are belong to and part of an alumni of this Chang University, that you will realize once you become a student like me. I'm sure that this institute will make you to feel proud and make you to widen your knowledge in the field of your research. Okay, and so now I'm moving towards introduction of my professor and what we do in our lab and what we are expecting from students who are willing to join our lab. And we'll go through the I'll show the papers and I'll show the research works which are being conducted in our environment. Okay, and so yeah, so he's our Professor Thomas Lei, who is also the OAD, and he's a professor in the Department of Biomedical Engineering in Chang University. Also, a professor is an adjunct research fellow in the Department of Radiation Oncology at the Chang Memorial Hospital, which is 5 miles apart from this main university, situated in the Linkou of Taiwan. And our professor is also an adjunct professor, serving as an adjunct professor in the Department of Electrical and Electronic Engineering at Yonsei University, which is presented at Korea. And he is also he's also nominated in the world's top 2 scientists, top 2% of scientists, and our professor is a fellow in Royal Society of Chemistry, and he's also a fellow in the Institute of Physics, which is present in the UK, and he's a chairperson of the Technical Committee on Nanorobotics and Nanomanufacturing, which is seen in the IEE NTC of USA, and he is also having more publication, and adding to his publication, he's also being served as an associate editor in the EMBS section of the IEEE Access Journal, and he's also an associate editor in the IEEE Transaction on Nanobioscience. This is a small introduction about our professor, Thomas Kin Fong Lei. Moving to our laboratory. So our laboratory is a kind of environment where we integrate engineering and where we integrate biology together to produce some devices which can be used to understand the cancer mechanism and to know more about how to make a proper intervention in the cancer cells, and to produce some point of care devices which can be used for detecting cancer in various stages. So our laboratory is also called as Biomems. So where Biomems stands for, bio represents biology, community on biological cells and biology environment. But MEMS, this is a new word. Obviously, this is not a new word. It was
Sorry,
coined in the
Praveen.
earlier.
Sorry, Praveen, you only have 5 minutes, okay? Sorry.
Yeah, sure.
Okay.
Yes, ma'am. I'll fill it up.
Yes.
So MEMS laboratory is nothing but it's a micro electromechanical systems where we miniature the system and where we create the environment in a miniature platform for better understanding and for better reproducibility of results related to the cancer. So we focus on microfluidics integration with the cancer. So which that is what called our Biomems laboratory. So the mission of our lab is to use the microfluidic technology to accelerate the study of cancer. And this is a paper which we have been worked. And this paper demonstrates how cell culture and migration system, that is, how a cell performs in a microfluidic channel and how it is being generated. The microfluidic system which is being generated is shown here by using various materials to fuse together. And by using the materials, by making the microfluidic substance, we have various electrodes. And by that, we able to calculate the movement of cell and the migration of the cells under impediments. Impediments is nothing but it's the word which is coined in biological chemistry to understand how the cell migrates from one to other. So with the help of this migration, we can calculate the cell how react to an environment. And this is better than the routine assays which are used for wound healing assays like that. So we are developing assay techniques which helps to identify cancer cells and their movement in a very microfluidic environment. So here you can see the quality of the cell's movement, and there are various reports being collected at the various hours. And similarly, we also looking in making a paper-based assays where the cost and where the technology is more wider and the cost is very cheap than compared to the very huge assays. So using the paper-based microreactors, we cell seed and we stabilize the cells in the culture medium, and we find out that various environment being provided in the paper and how cells react to the various environments. So these kinds of assays are being commonly done, and we are now into the microfluidics integration with the cancer, and hope I have been showing some results. Due to some time constraints, I would like to end it. But what kind of students can join our lab? This is the most important thing. Yeah, obviously, as Lynn ma'am said, and you should be highly motivated, and then you should have some hands-on experiments on running biological part. And if you're interested in cross-disciplinary research, of course, we are welcome, because we need mechanical engineers, electrical engineers, as well as biomedical scientists. So the works of a mechanical engineer, an electrical engineer, and biomedical science people are being described here. And you can have Snap, and you can also interact with me if you have any queries. And thank you for your attention. For more information, you can email to a professor, and as well as I am providing his email, as well as sharing the QR of our lab. Yeah, thank you, ma'am. Thank you for the
Thank you,
opportunity.
Praveen. Thank you. 教授，谢谢，真的谢谢们。Thank you very much, everybody. And then,
Thank you.
I mean, next time if we have the opportunity, we do it again. 谢谢，教授，谢谢。